Hello and welcome to this presentation from Protein Stable. My name is Alistair Davey and I'll be guiding you through the products available from Protein Stable and how they can help you measure protein stability. What shall be covered in this presentation starts with a brief description of the company and the main application areas our products are designed for. Next, the current technologies and methodologies will be highlighted, along with their issues and barriers to entry that make these approaches undesirable. Naturally, this will lead to covering the features that are desirable and the introduction of our two new products, SUPR-CM and SUPR-DSF. Finally, there are some application examples that will be covered, which will provide some ideas for how the SUPR systems can help in your protein development programs. As mentioned already, I'll begin with an introduction to Protein Stable. Protein Stable is a joint venture between Applied Photophysics and Fluorescence Innovations. With Applied Photophysics, we can leverage our 50 years of experience manufacturing spectroscopic instrumentation, and with Fluorescence Innovations, we incorporate new innovations in the high-throughput, low-volume methods for characterization of proteins for increased productivity. Exploiting recent advances in technology, our SUPR products are built to measure the conformational stability of proteins. Since the structure of a protein is integral to its functionality, it is important that any new biologics don't undergo any undesirable changes. And this doesn't just apply to the final product. From development, manufacturing, transport, and delivery to the patient, new biologics need to maintain conformational stability in order to remain effective. Any instability can lead to changes in the protein structure and could lead to aggregation, which will affect the biologic's therapeutic properties and introduce safety concerns. Conformational stability measurements are especially important at the early stages of development, since you don't want to invest the time and expense on poorly performing candidates. The challenge here is finding ways of screening hundreds of conditions quickly and without using lots of protein sample. So, in terms of measuring conformational stability, there is a range of products and methodologies available. There are methods like differential scanning calorimetry and circular dichroism that can measure unfolding across a temperature range, while approaches like dynamic light scattering and size exclusion chromatography can inform about potential aggregation issues. However, many of these methodologies and the traditional technologies built to do these measurements have issues, problems, or barriers to entry that prevent people from using them. These issues can be things like expensive proprietary consumables or long acquisition times. There might be a need to limit the throughput for better sensitivity, or the software used to run the system could be restrictive and difficult to use. All of these smaller issues can then lead to much larger issues where the time and cost of projects are increased, or there is a compromise between data quality and quantity that impacts your ability to make effective decisions. Obviously, at Protein Stable, we want to provide the opposite. We want to help you lower project costs and shorten project times, while providing you with more information so you can make more informed decisions about which candidate or condition to proceed with development. Ways we can achieve these goals include using low amounts of sample and leveraging the microplate format, having simpler sample preparation procedures while facilitating high throughput capabilities. Finally, we can take advantage of full, intrinsic spectral measurements that don't require extrinsic dyes and captures the whole spectral profile of your proteins. With that said, let me introduce you to the first of our products, SUPR-CM. SUPR-CM is a plate-based spectrofluorometer that is compatible with 96 and 384 well microplates. The system can measure protein concentrations down to around 0.015 mg per ml with a total well volume of 20 microliters. SUPR-CM has been designed to perform quick and easy measurements of conformational stability via the chemical denaturation method. And one of the advantages of chemical denaturation is the ability to measure your proteins at equilibrium, thus mitigating the kinetic effects of the thermal-based denaturation approach. Our SUPR products utilize a spectrometer array detector that captures fluorescence spectra between 310 nanometers and 420 nanometers with excitation at 280 nanometers. The main advantage of using the spectrometer detector is that our plate acquisition times are short. For example, the fluorescence spectra for a full 384 well microplate can be measured in around 2.5 minutes. Both our SUPR systems can be integrated into pre-existing automation setups via our API, but we also offer a full automation suite that includes liquid handling and a robotic system for moving microplates between systems. The next product from Protein Stable is the SUPR-DSF. The SUPR-DSF is a spectrofluorometer that is compatible with 384 well PCR microplates. The system can measure protein concentrations down to around 0.1 mg per mil with a total well volume of 20 microliters. The SUPR-DSF has been designed to facilitate conformational stability measurements via thermal denaturation. However, you do not lose the capability of performing chemical denaturation experiments, opening up the opportunity to perform orthogonal measurements on one system. Similar to SUPR-CM, the SUPR-DSF takes advantage of an array spectrometer detector to measure the intrinsic fluorescence of proteins from 310 nanometers to 420 nanometers, with an excitation wavelength of 280 nanometers. This allows the SUPR-DSF to measure a full 384 well microplate of samples in around 90 minutes. Thermal measurements can be from 10 degrees up to 100 degrees Celsius. Now with our two products introduced, let's delve into some application examples, including formulation, mutant screening, and ligand binding. Our first example here investigates the stabilizing effect of different formulation conditions. This is typically the stage after the biologic candidate has been selected. However, given a large number of possible conditions, it becomes a challenge to efficiently screen the hundreds of formulation conditions and determine which subset should be selected for further development or refinement, thus necessitating the measurement technique that can achieve high throughput capabilities. Our experiment investigated the potentially stabilizing effects of 95 different conditions on the same therapeutic antibody, trastuzumab. All conditions could be screened within one 384 well microplate and only needed one thermal denaturation experiment to acquire all the spectral data needed. You can see from the plot of fraction unfolded that the antibody goes through a three-state unfolding process with visually clear plateaus for the folded, intermediate and unfolded states. Via least squared regression analysis done within the SUPR suite software, the midpoint of inflection, the TM values, and the entropy values have been quantified. With TM values around 73 to 75 degrees and 81 to 86 degrees being measured, this is in good agreement with the reported values measured via DSC. Additionally, we were able to identify within our subgroup of stabilizing excipients two of the components that are used in the actual drug formulation branded as Herceptin. This provides strong evidence of the measurement capabilities of SUPR-DSF, while illustrating that high-throughput screening processes can be achieved easily and with fewer consumable costs. Our next examples look at using the SUPR systems for screening different mutants of a parent antibody. Challenges here can involve sample amounts and sensitivity of the measurement. Since some of the alterations made to the proteins are small, you may require a measurement technique capable of picking up on the resulting small impacts on stability. The example shown here looks at the oxidation effect seen when hydrogen peroxide was mixed with an IgG monoclonal antibody. From the fraction unfolded plot, it is clear that the peroxide treatment has affected one transition region, while the second transition region remains unaffected. This is further illustrated by looking at the results of fitting a three-state model to the denaturation curves. The decrease in CM for the first transition is significant, while the change in CM2 values is negligible. These results demonstrate the SUPR system's ability to measure the subtle changes in the stability of proteins. Following on from the peroxide treatment, we now look at a screening measurement of different mutants of a wild-type protein. All 15 mutants plus parent protein were measured in triplicate on one microplate, and the fluorescence was measured from 60 to 100 degrees Celsius. The grouped plots on the left show the change in denaturation profile compared to the wild-type protein. The fraction unfolded plot on the right shows a subset of the mutants measured and highlights the mutants that improved the conformational stability of the protein. Not only was the experiment simple to prepare, but with only 48 wells being used, there is the possibility of expanding the number of mutants being compared or combining multiple project samples onto the same microplate to increase efficiency and lower consumable costs. Our last example looks at how the SUPR systems can be used to assess the binding of ligands to proteins. In order to obtain enough data points to determine KD values, you need to measure the protein denaturation at many ligand concentrations. This can be time-consuming with other systems and require multiple runs of the system to capture all the necessary data points. However, with SUPR-DSF, it was possible to measure at many ligand concentrations for 3 different ligands, all with the same microplate and all with one thermal denaturation run of 90 minutes. With the last application example covered, allow me to summarise. The new products from Protein Stable are advanced plate-based spectrofluorometers that are capable of high-throughput measurements of protein conformational stability. By leveraging low sample amounts in industry-standard microplates, the SUPR systems can help reduce project costs. And there is no need to compromise on data quality, as our systems are able to capture multi-state behaviour via intrinsic fluorescence measurements. With Protein Stable, you can perform both chemical and thermal denaturation experiments, which can provide an orthogonal approach to assessing your samples. Finally, with our intuitive, easy-to-use software, you're able to quantify the conformational stability of proteins via thermodynamic properties like the Gibbs free energy value and Van Hoff entropy. And with that, we have come to the end of the presentation. I would like to thank you for listening, and should you wish for more information, consult our website at www.proteinstable.com or contact us at sales@proteinstable.com.